Hello everyone. Hi, sorry for being late. Yeah, so today we are expected to start doing chapter number 14, which is about normalization. And this is a process that can be applied on the databases to remove any repeating groups. Okay, removing repeating groups or normalizing relations. So if we normalize relations, it means that we are getting rid of any redundant data. Okay, so this is basically the the main concept of normalization. So the database will be easier to be understood, easier to be used. All right, all the relations will be easier. They will be facilitating accessing data and data consistency and reliability. All these will be ensured if the data or actions in the database are normalized. Before I go through this chapter slide, I need you to tell me if you have any question related to the previous chapters. ER, for example, ER diagram, EER, how to draw the ER diagram, how to draw the EER diagram. Do you have any question? For example, chapter number 13, it's not about reading the book or reading the slides and then memorizing information and answering questions, because some questions will be like drawing. It will be based on your understanding. So I want you to tell me if you have any question, right? Don't hesitate. For example, if I have scenario, I will provide a scenario and then database scenario, and then I will ask you to do or to create an ER diagram. So do you have any question, guys? Any question? Like, for example, you want me to show you how to draw it, or yeah, no one? Anyone can tell? Just a minute, guys. You are with me, guys? Can you hear me? Okay, okay, perfect. Um, because yeah, based on the quiz, I expected more or higher marks, so that's why I'm asking here. Try to understand the main concept, and based on that, um, just a minute, guys. Based on that, have a general understanding about the AR diagram. Just a minute. All right. Okay. So, the main objectives of this chapter slide um, will be discussing the purpose of normalization. What is the meaning of normalization? And then how it can be used
when we design relational database, relational means it includes relations, which means tables, all right? Okay, and what are the problems if there are redundant data in base relations? What kind of problems we can see in relations with redundant data or with repeating groups, or duplicated, duplicated data? And what are the functional dependencies? How we can describe the relationship between attributes using the functional dependencies. Then we are going to discuss the characteristics of functional dependencies. In order to have the process of normalization, we need to determine the functional dependencies first. Okay, so the process of normalization will be in 2 stages. Let's say not 2 stages. There are steps. Step number 1, identify the primary key or the foreign key, then identify the functional dependencies. Then later on we can go through the process of normalization. How to identify functional dependencies? This is what you are going to learn in this chapter. And how functional dependencies identify the primary key. And then we will go through, as you can see here, we will go through the process of normalization. So first, identifying functional dependencies, okay? Then identifying the keys, the primary key, for example, or any candidate key. Then we go through the process of normalization, all right? Yeah, how we can use, or how our normalization can use functional dependency to group attributes into relations that are in a non-formal form. So it must be a normal form. Okay. Then we are going to discuss what is the meaning of the first normal form. Okay. The first normal form. Then second normal form. And third normal form. So we will just have this. There are more normal forms, but we are going to focus on the first 3 normal forms. Okay, only first normal form, second normal form, and third normal form. First, before we go through the first normal form, second and third, we will identify the function dependency to group any attribute to having a normal form, just a group of attributes. Then we separate it into some kind of relations. It means that we are going to focus on a base relation. We remove the repeating groups or redundant data. We define or identify the functional dependencies, and we are going to focus on that. So don't worry about it. We will discuss it. Then after that, we will identify the primary key, and then we will have these processes: first normal form, second and third. Then there will be we will notice some problems if we break the rules in the first normal form, second and or third. Okay, so there will be a problems if that will break the rules of first, second, and third normal form. Just a minute, I'll just fix the power. Then we will we will learn how to represent attributes in a form of third normal form relations using normalization. Okay, so basically just you need to understand what is the meaning of normalization and how we are going to normalize relations. Okay, how we are going to normalize the relations? There will be steps. Okay, as I said. Now, we need to to understand that the main objective of the database design is to create an accurate or consistent representation of data. Everything must be accurate, all right? Either it's data, its relationships between data, or the constraints, okay? To do this, we need to have two techniques, ER modeling, and we use normalization. ER modeling, we finished doing this. We have discussed how to draw, sorry for that. We discussed how to draw the ER diagram based on the requirements and the entity types available in any organization, okay? And then we learn how to represent data using some semantic information. We learn how to enhance this ER model to become EER model, all right? So this is one way to represent data relationship and constraints about the database or constraints related to the database using ER model to have an accurate or consistent representation. Okay, this is one way. Another way is normalization, which we will discuss in this chapter slide. Now, some attributes describe, we know that it's describing some property of data or the relationship between the data, and it's important to have attributes, all right? Important to have attributes. What the normalization do here, the attributes will have some property, will provide some property of data, and will have some relationship among different attributes, all right? There will be different relationship between attributes. The main role of normalization will be examining the relationship between attributes, okay? So this is the main point here. Examining the relationship between attributes. This is the main role of normalization. We are examining the relationship, which means functional dependencies. The relationship between attributes is known as functional dependencies, okay? So we will use some tests, series of tests. We call it normal forms and normal forms, all right? And we will identify any grouping of these attributes. We will identify some suitable set of relations, okay? And if there is any duplicated data, we will divide or separate it from the base relation and have new relations, because we need to have, at the end of the day, we need to have a normalized relation with no repeating groups, with no redundant data, okay? Otherwise, there will be problems if we have some repeating groups. Okay, so the normalization will be or can be defined as a technique to produce set of relation, okay, with no or suitable set of relation that support the requirement of the enterprise with no redundant data. All right. So the definition of normalization, it can be defined as a technique that is producing set of relation to describe properties or attributes to support the data requirements of an enterprise. So identify suitable set of relation. This is the main point here. The main purpose is identifying suitable set of relations, okay? Suitable set of relation means there will be no repeating groups, there will be no redundant data, and it will be tested under series of normal forms, okay? So this is the meaning of normalization. Normalization, it can be used, or it's a technique used to identify suitable set of relations. You can count this as a definition, okay? This is the definition as well. In other words, you can say normalization is a process or a technique that is used to identify a suitable set of relations, and inside a bracket you can add without redundant data, okay, or with no redundant data, which supports data requirements of an enterprise. Okay, so this is the definition of normalization. What are the main characteristics of suitable set of relation? What are the main characteristics? Now you will learn that the suitable set of relation must be the minimum number of attributes necessary to represent data of an enterprise. So there must be minimum number of attributes. Minimal number of attributes. So this is number one. And it must be with close logical relationship together within the same relation. Number two, all attributes within the relation must be with a close logical relationship in the same relation. Minimal means here that there will be no redundant data, okay? Which means that the attributes will be represented only once. The attribute will be represented only once, okay? With any exception of attributes that can be part of foreign keys. This is something, this is a must. If we have a foreign key, for example, related to the base relation, it's a must to have this attribute because it's a foreign key. This is just an exception, okay? But otherwise, we need to have attributes with no redundant data, which appears only once in the same relation. Or in related relations, and it has a close logical relationship between other attributes. All right, so these are main characteristics of suitable set of relation. Okay, that's the meaning of suitable set of relations. Let me just have this. So what are the main characteristics? They are two: minimal number of attributes, and attributes must be with close logical relationship. Minimal number of attributes means no redundant data. It has only one appearance within the same relation, with an exception of having foreign key attributes. Okay, now the main benefit of a database that has a suitable set of relation, what is the benefit? It will be easier to access. As I said, it will be easier to maintain the data. There will be less storage space taken by the database. Okay, so these are three benefits of having normalization or normalized relations. Number one, it will be easier to access it. It will be easier to maintain it. Easier to access, easier to maintain, and will be minimum, or it will reduce the storage space required for the database. This is the main benefit of having such kind of relations, okay, normalized relations. Okay, the major aim of relational database design. Now let's focus on relational database design. Relational database design means it has what? Relations. Relation means some kind of tables used to represent data. This is the relation, okay? It means table. It has consisting of columns and rows, all right? This is the relation, relational database design. Okay, so the major aim is having to group attributes, and minimize data redundancy, all right? So we will minimize data redundancy. So we have a group attributes into relations, and this will make it easier to update these attributes. So it will be, the benefit will be easier to update. Okay, updates will be achieved, minimal number of operations, and will reduce any opportunity to data or for data inconsistency. Also will be, this is exactly same as we have discussed in the previous slide. It will reduce the file storage space required by the base relation. So two things here. Removing any or minimizing data redundancy will make it easier to update. So let's add this here. So it will be easy to access, easy to maintain, and it will reduce storage space. We will add easy. So easy to what? Easy to access, maintain, update, and reduce storage space required. Okay, so all these are some benefits of having normalized data with minimal data redundancy. Okay, let's just take, this is just an introduction for this chapter. I want you to understand this process before we go through more details. All right, now relational database will be having there will be data redundancy. It must be it relies on the existence of a certain amount of data redundancy. There is data redundancy, okay? So it's normal to have data redundancy within a relational database. But it's in the form of copies, like, for example, primary keys, okay? If we have foreign keys in another relation, it will be related to that primary key. Like, let's focus on these relations, three relations. We have staff relation, branch relation, and staff branch relation. See, staff relation will include number of attributes, okay? So for example, staff number, staff name, position, salary, branch number, all right? Branch number. And on the other hand, we have the branch relation, including branch number and branch address. All right, now when we combine these relations together, there will be what? Staff branch relation. Okay, this is the alternative form of the staff standalone and branch standalone relations. Okay, so if we combine these relations together, we will have redundancy. There will be redundancy. Why? Because, see, look at the staff number here, staff name. This is okay. All right. If we combine these together, there will be more than one branch number repeated, because more than one staff member will work or will belong to the same branch, right? Even the position here. Okay, you can see here, what is the meaning of redundancy, data redundancy? It means that branch number, I have, see here, branch 003, branch 003, and same with the address. It's redundant, right? Repeated. This is also branch 003. There is branch 005, also repeated. Why? Because it's a foreign key. What is it? It's a foreign key. Foreign key for what? Foreign key for the branch relation. So if we have combined these two relations together, we have group the relations together, we will have sort of redundancy, data redundancy, which is what you can see here, the foreign key related to some attributes in another base relation. Okay, so these are base relation, branch base relation, staff base relation, and staff branch relation is created based on these two base relations. So any relations that are having redundant data may have problems. What are the problems? We call them update anomalies. Okay, the problems appears when in relations with redundant data can be known as update anomalies. What are these? Can be classified in three problems or three update anomalies. Number one, insertion update anomalies, something related to inserting data. When we insert data, there will be problem in accepting this. Number two, deletion anomalies, a problem associated with deleting, if we delete, for example, a record. And number three, modification anomalies. Let's talk about this example just for the last minute. Here, if we, for example, insert a new branch number, and there is no staff number assigned to this branch, is it possible to add the branch number here in this relation? If we don't have, for example, here, let's focus on this relation. Let's focus on a staff branch relation. If we insert a new branch to this relation where there is no staff members assigned to this branch yet, can we do that? Can we do that? We cannot, because why? Because there is a primary key here. A staff number is a primary key. It cannot be null, right? So this is a problem we call insertion anomalies. Insertion. When we insert a new record for the branch number, for example, there will be a problem related to the primary key where the primary key value cannot be null. Same with the deleting. If we delete, for example, this staff member, which is belonging to, for example, branch number 007. When we delete it, this staff member. When we delete Mary, for example, the branch will be deleted as well from the database. This is the big problem, okay? And this is a deletion anomalies. Same with the modification. When we, for example, modify or update the address for a branch for B003, it will not be updated automatically for all B003. We need to update it manually, all right, for all branches here. Okay, so this is the modification anomalies. These are problems appearing when we have redundant data that are classified as insertion anomalies, deletion anomalies, and modification anomalies. Do you have any question, guys? So these are this was just an introduction for this chapter slide. Do you have any question? All right, perfect. Okay, just let me take the attendance. Okay. Well, thank you so much for attending today. That was all for today's lecture. Just a minute, guys. I think it's not. Okay, so that was all for today. Thank you so much. See you next time, inshallah. And if you have any question, don't hesitate to ask. I am here. I came to the class, to the classroom. I thought that there are some students here, but no one attended today. So yeah, if you have any questions, because these chapter slides are hard to be understood without face-to-face attendance, you know. It's hard to be understood because I'm drawing on the board. I'm having some activities in the class. So that's why. I know, I understand that it's Ramadan, and Ramadan Mubarak, inshallah. May Allah accept your prayers and your fasting, inshallah. Thank you so much for attending today. See you next time, inshallah.